everybody. Welcome to Kitchen Biology. And in this episode, we're going to learn about biogeochemical cycles. And you are watching, you're doing a PowerPoint and questions, but these are the demonstrations that had we been in class, we would be doing these labs, and it would take us about 2 weeks to actually do these labs. So what we're going to do in biogeochemical cycles is we're learning about the movement of carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. But the two that we can focus on are carbon and oxygen, carbon dioxide. They're really easy to play with, and you're going to see that in these labs. Hydrogen, phosphorus, sulfur, nitrogen, a lot more difficult to do in these kind of lab settings. But I want you to recognize that by following carbon and oxygen in the form of carbon dioxide, all of these other chemicals are going to be moving too. And we're going to take a look at, the idea is we're going to take a look at how these things move between, how these elements move between the air, plants, animals, water, soil, rocks, bacteria, how this stuff moves globally on our planet between the living, the biotic, and the non-living, the abiotic. So here we go. So before we begin, I got to show you the indicator that we're going to work with. And the indicator is a pH indicator. It's called bromothiamol blue, or BTB for short. And you can see that it's a pretty dark bluish green liquid, and this is what it does when it's in just tap water, is it has kind of this green turquoise blue tint to it. So at a pH that's neutral, BTB will be kind of a blue-green color. But look what happens when we add a little bit of acid, vinegar to it. Look at that, bright yellow. So we're going to remember that BTB is yellow in anything acidic. Anything that's a pH of 1 to 6, it's going to be yellow, okay? The next one, though, is we're going to use baking soda. Baking soda is a base. So we're going to add a little bit of baking soda to this one, and look what it does. And you guys can remember that BTB is blue in base. It's green in neutral, and it's yellow in acidic, okay, in acid. All right, so we're going to remember that, and we're going to be using BTB in the rest of our little demonstrations here. All right, so let's take a look at this one. And I want to show you what I've set up. This one, CO2, wow, what a gas. All right, and I've got 3 tubes set up here, one with water, and 2 of them with water and carbon dioxide. The next one I've got here are 2 bottles of water, and this one we're going to do something special. We're going to put carbon dioxide into just one of them. And this last one is the probability of solubility. We're going to take a look at how carbon dioxide moves in cold and warm water. And these are just bottles of soda water. All right. Now to get this started, we needed carbonated water. So we just used our soda stream, and we used the canister here, and we just pressurized it and put carbon dioxide in the water and dissolved CO2 in the water. All right. So here we've got just the plain water. So this is going to be our control. And let's put just a few drops of BTB in there and mix it up. And that tells us that it's a neutral, maybe even just a tiny bit basic, but it's neutral, all right? Now, this is an interesting one, the water and the carbon dioxide. What do you think it's going to do? Let's look. Look at that. It turns yellow. Now that's an interesting idea, because the carbon dioxide added to the water makes a weak acid. It's called carbonic acid. And you're going to be learning about that in the rest of the PowerPoint here. All right? And then this one. Here we go. Add a few drops to that, and same thing, it's bright yellow. But we're going to do something bizarre. just like a can of soda pop, we're gonna take this one and we're gonna shake it up. Well, you guys know what happens. That fizz is what? Carbon dioxide. If we open the bottle and then we keep shaking and open it again, keep shaking, and you know that the carbon dioxide is what's causing that fizz. Every kid knows that who's ever had soda pop. And I'm just going to set this aside. I'm going to come back to this one in a few minutes. All right? We're going to come back to that one. And I want to get started on the next ones. All right? Now let's take a look at this one right here. All right? I got 2 bottles of water. All right? But this one, I'm going to put in a chunk of dry ice. Now the first observation I want you to make is, and you know what dry ice is, cold, compressed carbon dioxide. The 3 phases of carbon dioxide: solid, liquid, and gas. Notice how it's just vaporizing. It's called sublimation when it goes from a solid to a gas, okay? And notice the other thing. Notice where CO2 is going. It's falling, all right? So we're gonna put it in this beaker like this. And we're just gonna let it fall into that beaker for a little while. And we're gonna come back to it, okay? Now, we're gonna take a look at this one. This is the probability of solubility. And in this one, we're gonna take a look at carbon dioxide moving through cold or warm water. Now this is important because think about Northwest and think about, like, I don't know, Hawaii, the Caribbean, okay? So let's take a look at these 2. We've got a bottle of soda water soaking in cold and a bottle of soda water soaking in the warm. What we're gonna do is we're gonna open these up. And I want you to watch the bubbles. Where do the bubbles move faster and bigger? Okay, okay, are you ready? Okay, got it? Here we go. So we're gonna open this one and I want you to watch the movement of the bubbles, the size and the rate of the movement. Whew! Look at those big, fast moving bubbles. Now let's look at the cold one. Notice that carbon dioxide is less soluble in warm water. That means it's coming out of the warm water. It doesn't stay dissolved. In cold water, the carbon dioxide stays dissolved in the cold water. So now you know something about the movement of carbon dioxide coming out of warm water and cold water. All right, so now let's go back to these 2. All right, let's go back to these 2. Look at this. This is astonishing. After just a few minutes, that carbon dioxide has fallen into this water. And what's it done to the water? Remember? If it's yellow, it's acidic. All right? And look what's happening to this one. It hasn't gone very far yet. But look at this one. As we shake it up, what's happening to the color? That's right. It's losing its carbon dioxide and it's becoming more neutral and towards the neutral zone. All right? So now I want you to continue with your PowerPoint and we'll watch the next one. Bye.